So in this video, we're going to do a sample with the ion bromate. And what I'm going to do is I'm going to go through the process of solving it. And then we're going to talk about how you game plan setting these kind of things up. So we're going to go through the same kind of process that we went through before. We'll draw some possible Lewis structures. I'm usually going to ask for three. And when you do this, you really need to make sure that you have the best structure as one of the three that you choose. And we'll talk at the end of this video about how you do that. Then you assign your formal charge to every single atom. You check your work in that the formal charge should add up to the charge of the ion or the molecule, and then you determine your best structure. So here I have the three possible structures, okay? And I have selected, here's my best structure. And again, I'll tell you at the end how you do that. I do a structure that has one more double bond than the best structure and one less double bond than the best structure. So the best structure has two double bonds, one less has one more has three. Let's not belabor that point. Now, a lot of these compounds are going to have oxygen in them. And so you're going to have mixtures of single bonded oxygen and double bonded oxygen. You should never have a triple bonded oxygen because it has a formal charge of 1, and that is bad. Okay? So let's start with a single bonded oxygen. And remember that the formal charge on a single bonded oxygen is always going to be the same. Okay? So that formal charge is going to be, oxygen has 6 valence electrons. There are 2, 4, 6 electrons in lone pairs. There are 2 electrons in this bonded pair, so 2 over 2, and that gives me a formal charge of -1. That means that a single bonded oxygen always has a charge of -1. Now, when you do this, you're going to still need to show me this calculation. You can't just say, hey, I know that single bonded oxygens have a formal charge of -1. You could always put it in, and then at the end of the assessment, go back and fill in the work. But it needs to be there to get full credit, okay? So then I also have a double bonded oxygen, and a double bonded oxygen has a formal charge of 6 minus. Now there are 2 4 electrons in lone pairs and 2 4 electrons in bonded pairs. And that is going to give me a formal charge of 0 on double bonded oxygens. So I fill in all my double bonded oxygens as formal charge of 0. Okay? So now we have to go through and do all of the central atoms, all of the bromines. Okay, so the formal charge in this one, bromine has 7 valence electrons minus 2 electrons in lone pairs, minus 2, 4, 6, 8 electrons in bonded pairs. 8 over 2 is 4, minus 2 more is minus 6, so 7 minus 6 is plus 1. So that bromine has a charge of plus 1. This one, this formal charge is 7 minus 2, and then we have 2 more electrons, so 2, 4, 6, 8, 10 electrons. And that's going to give me a formal charge of 0. And then this one, 7 minus 2 minus 12 over 2 this time, and that gives me a charge of -1. Okay? So now we go through and figure out which one's the best structure. So positive formal charge only on a central atom. Okay? So we don't have any oxygens that have any positive formal charges, so that's good. Then formal charge other than +1, 0, -1 are bad. We don't have any of those. Everything's -1, +1, or 0. The least number of atoms with formal charge on them. Okay, well, the best structure has one atom that has a formal charge on it. The +1 double bond has a structure that has 1. This one has 3, so we can go ahead and eliminate this structure. Okay? Now we go down to our last thing. Electronegative atoms should have negative charges. All right, so between oxygen and bromine, oxygen is more electronegative, which means that this structure is correct because the negative charge is on the oxygen and not on the bromine. Okay, so there's our best structure. Now, how do I select which one is correct? Okay, that goes back to what I've been talking about this whole time. A single bonded oxygen always has a charge of -1, and a double bonded oxygen always has a charge of 0. So because this compound, or this ion, was BrO3 minus, I know that the formal charge of my ion, my structure, has to add up to -1, which means, and since I am going to have single bonded oxygens with a charge of -1 and double bonded oxygens with a charge of 0, the number of single bonded oxygens is going to be the charge, right? Like, there is one single bonded oxygen in the best structure to give me a charge of -1. Okay, that's how you pick the best structure. So if, for example, I think of something like SO3 2 minus. Okay, so if I think about this, this means that I have 2 single bonds, and that means 1 double bond. So my best structure for this is 1 double bond with 2 single bonds, okay? And then I can fill in the rest from there. But it is very important that you pick the best structure. And that's really it for this video and for formal charge.